mic, but actually the audio system doesn't work, unfortunately. This is just for the live stream that we're also posting on YouTube for people who didn't arrive. So yeah, just hopefully you can hear me. Can you hear me at the back there? All right, yeah, I'll try to speak louder, but I mean, it's also for the presentations later. So, I mean, first of all, thanks a lot for coming on time and in such a good attendance. So first time organizing that meetup, all in Kubernetes, meaning that the underlying topic or underlying theme or overarching theme of that meetup is all in Kubernetes, so AI, data, databases, all kinds of stateful workloads, really all about using Kubernetes as a orchestration layer for the cloud, for bare metal, for everything. And we'll try to match the topics with that kind of theme. The idea is to really go around a little bit, so go also to different cities, and not only stick to Berlin, but I think if the attendance continues to be so well, and obviously if the feedback is good, we'll be trying to repeat it as often as possible in Berlin. And obviously all kinds of feedback, all kinds of contributions in terms of speaking engagements, any kind of tips are appreciated. So thank you very much for coming. And I just wanted to introduce quickly us, SimplyBlock, so just 2 minutes. So we're one of the organizers of this meetup. We're an NVMe first Kubernetes storage. What does it mean? And who we are. So let's see if that works or not. Maybe it doesn't work. Okay. There you go. Okay. Yeah. So just quick facts on SimplyBlock. So we're Berlin based, but remote first. So most of our team is actually not here. But today we have myself, Chris, and Walid at the back, one of our engineers. So it's 3 of us today here. We're VC funded, so Antler is actually one of our investors, and it's actually our first investor. We also have some other investors, and we're growing fast. We're actually hiring, as some of you know. So please check out our job postings on the website or on the LinkedIn, and we're looking for talented engineers all the time. Yeah. Oh, so it's a bit. Yeah. So this is a bit complex slide, but I mean, I'm not going to go very deep into that, just to understand what SimplyBlock is. So SimplyBlock is, first of all, storage solution. It's storage solution optimized for Kubernetes. We are providing high-performance storage access to Kubernetes workloads like databases, so low latency, high throughput, high IOPS. We have a lot of features in our system that are really good for developers, for infrastructure engineers, for platform engineers. It's really a modern type of storage, and it's Kubernetes native, which means it can run on Kubernetes, it can run outside of Kubernetes on plain Linux, and it can provide a lot of value to your infrastructures. One of the, I think, yeah, actually I wanted to go. Okay. Yeah, one of the cool things I think that Chris will later demo very briefly is our copy on write functionality, where you can actually make a live copy of your database without consuming additional storage for it. So it's really good for testing and development. It can speed up your test and development on Postgres, on any kind of other databases, and especially if you run it in Kubernetes. So if you operate databases in Kubernetes, such technology can be really a good fit, and that's really what we're building for. But yeah, any feedback is appreciated, and obviously we'll happy to share more during the meetup or during the networking session more about us. And I think about the agenda, so we'll try to stick to agenda. Frederic will introduce, Frederic number 1 will introduce Antler very quickly, and then Frederic number 2 will start the session on Kubernetes network traffic monitor, open source tool. And after that, we're going to have a quick break to switch to Chris's session, Postgres on Kubernetes. After that, pizza will arrive, and we'll have a networking session and hopefully a couple more beers and have some good chats. So that's the plan, and I hand over to Frederic.
Thank you very much.
All right, give me just a second.
No stress.
No stress. Maybe. There you go.
That's us. Well, it's not me, but it's us.
There you go.
Okay, I'm Freddy. We just want to quickly introduce ourselves so you know where you're actually sitting. This is not SimplyBlock's office.
Not yet.
At least as far as I'm concerned. So I'm Freddy. I work at Antler. We are a global pre-seed venture capital fund, and we support founders very, very early. So actually, if you are now finding yourself wanting to found a company and not wanting to join SimplyBlock, we're the right place for you to come. We run cohorts 2 to 3 times a year, all around the globe. Can you, I go on the next slide here, I guess. Perfect. So we run cohorts all around the globe, 2 to 3 times a year. And we figured one thing out from angel investing. Founders typically very early in their journey look for a few things. And this is also how Rob joined us here. So we have different profiles of people. We have business guys and girls, domain people, and founders with a technological background. You meet here for 11 weeks. We offer you a base or a platform to meet co-founders, to work on an idea that you come up with, or other people that are coming here. We do different sparrings. We in the end also invest. And we try to be helpful with our network. So when you look at the journey, we're very, very much at the beginning. Only later you have pre-seed VCs, seed VCs, and then even later growth stage VCs. So if you find yourself in a spot where you say, hey, I'm thinking of founding, or I have just founded with a team, and I'm looking for this kind of support base where you will have 90 people working together in this office. We're together with Amsterdam and Munich, overall 200 people. And you say this kind of support from a money perspective, from a content perspective, or you look for people to do it with from different backgrounds. This is your place to do that. That's our footprint. We're only 6 years old. Originally founded in Singapore, but by now have 28 offices, around 1,500 portfolio companies. We had, I think, 9,000 people going through our residencies. We have a yearly application rate of 150,000 people. So by now, I think we're the biggest tech talent pool in the world. How these residencies look. So for example, the next one coming up around 6 weeks before we start, we always have a pre-residency where all the founders already meet, who have already signed to join. First 2 weeks, we don't match people, but instead we create a platform for you to meet on an accelerated basis. So we don't just pour you in an office and you drink coffee all day and talk about your caffeine shock. But we actually do a bit of challenges based on content. So you kind of have a feeling like, hey, that person, discussing with that person was actually fun, and this person I really don't like. So you can kind of figure out for yourself what you want to do. And then you just build whatever with whoever you want to build with. And use us as support tool to actually make you faster and hopefully even better. In the end, there's an investment committee. If you want to ask things about how it is as a founder, Rob is your man here. And yeah, that's a bit the background. So as I said, in the 3 offices, Amsterdam, Berlin, Munich, we always have like 180 to 200 people at the same time. Business, domain, and tech is split pretty much 50-50. On average, people have 11 years of work experience. Around about half of the people who's not on the slide have actually built a company before joining us. And it's 50 plus nationalities. I think it is, the minority is German. Whether that's a good thing or bad thing in this crowd, I don't know. But it's the case. So if you're actually interested, hit me up, hit up my colleague Felix, my Felix colleague. Marius, also one of our technical founders who's secretly hiding there, or Rob. We also put the QR code there, you can scan it. We run a Meet an Antler partner session every Thursday where you can just listen in, ask questions, and happy to answer anything this evening as well. So thanks for listening, and happy to have you all in our office and have a fun evening. Thanks. Where does this go?
Wenn du da drauf klickst, und dann
nee, warte, das.
Anyone wants to tell a dad joke in between? Typically helps to kill time.
Eigentlich musst du auswählen.
Nee, will er nicht machen, aber es geht hier auch.
Okay.
Nee, kleinen Moment.
Wir sehen deinen Screen auf jeden Fall.
Ja, aber hier nicht.
Achso, ist das umgedreht?
Ja.
To mirror.
Ich würde sagen, eigentlich
Use S and then
genau,
mirror.
und dann Mirror.
Missklickt.
Perfekt. Sag mal was.
Test, Test?
Jupp.
Okay. Okay, I understand this is a 45-minute slot. I finished the slides like 2 minutes before heading out here, so I have no idea how long this is going to take. I'm actually going to time myself so that I don't go over too much. Let's see, where is it here? So, I'm Frederic. I'm the founder of this company called Polar Signals. I'll talk a little bit about what we do, but the main topic today is going to be about understanding cross-zone traffic on cloud providers. So the first thing during preparation for this, I realized this is not a super well-known fact. When you have availability zones on cloud providers, they're actually completely separate data centers that are typically anywhere between 20 to 100 kilometers away from each other. And then obviously they have completely separate electricity, internet connections, and so on. And so when you deploy, let's say on Google Cloud or something, and you have your Kubernetes cluster, and it's multi-zone, then you're just scheduling some pod. It may be in one of those availability zone data centers. So we're maybe not actively always thinking about this. And so why does that matter? It matters for a variety of reasons, and it might matter for you for a totally different reason why it matters to us. The first thing may be for cost. If your network traffic stays within the same zone, so basically within the same data center, that is free on most cloud providers. Whereas even if within the same region, so like geographically, the data centers are still very close, but even then, network traffic is not free and costs about 1 cent per gigabyte. This is kind of average across various cloud providers. The next thing, it depends a little bit on kind of what exact instances you're using on your cloud provider, but most of the time you get significantly less throughput as well, which can also matter a great deal. So if we are looking at the 25 gigabit per gigabit per second, we're talking about something like 50 milliseconds for a gigabyte transferred, versus like 500 milliseconds for cross zone. So that can make a huge difference, right? And then latency, this probably depends on whether you're an extremely low latency workload, but it can matter as well. When we're in the same zone, we have anywhere between 0.3 milliseconds to roughly 1 millisecond. If we're crossing the zone, it's anywhere between 0.8 milliseconds to almost 2 milliseconds. So obviously this makes sense, right? Like we are bound by the laws of physics. Our network traffic can only be as fast as light. And so if it needs to travel 100 kilometers, for example, then these kinds of latencies can certainly happen. So this is why same zone versus cross zone network traffic matters a great deal. If you really need to know, actually, as I was researching some of this data, because we're only exposed to a certain set of cloud providers within a certain set of regions, there's actually a really cool paper that analyzed these latencies across a bunch of different cloud providers, a bunch of different regions, and a bunch of different zones, and basically. Long story short is it varies dramatically across all of those things. Nothing's the same, so basically choose your cloud provider, choose your region, and perhaps even choose your specific availability zones. They all matter a great deal, specifically when we're talking about latency. But why do we care at Polar Signals? We care basically because of this. We realized this at some point last year that cross-zone traffic was making up nearly half of our cloud bill. This wasn't necessarily completely unexpected, but as our business grew, our cloud bill grows, and so eventually this actually became a problem. Where do we go? Maybe at this point it's a little bit important to talk about exactly what our product is so that we understand why this problem occurs. So at Polar Signals, we've created what's called a continuous profiling product. Maybe people are familiar with regular profiling of software, where you're basically looking at where in my source code is CPU time being spent, right? And you can see that down to the source code line number. Typically, profilers are used kind of one-off, on demand. You're maybe looking at one process in your infrastructure for like a 10-second period of time, and you look at, within those 10 seconds, what was my process doing? And that's really useful, but kind of has exactly the same problems as all other kind of production issues, which is you're probably not looking when the interesting thing happens that you really want to find out about. And so we've created this continuous profiler that always profiles all of your production infrastructure all the time. The simplest thing that gets you is you always have all this data, so that when an incident happens, you can just go back in time. This talk is not about our product, so I'm going to stop here in terms of the explanation. I just want to give you a really, really quick look at the product and what the end result looks like, because hopefully that gives you an idea. So what you're seeing is kind of our entire infrastructure, and you're seeing down to the source code line number where CPU time is being spent. And the wider the frame, the more CPU time is being spent. Again, if you're interested in any of this, if this doesn't make sense, that's okay. We can chat afterwards. If the only thing you take away from this is that our customers send us an enormous amount of data every day, that's really all you need to know for the purpose of this talk. And so that is naturally why this is a problem for us. We have our customers sending terabytes upon terabytes of data every day from every single node in their Kubernetes clusters, and we need to deal with all of this data. We need to store it, we need to analyze it, we need to query it, we need to visualize it, all of this good stuff. Lots of numbers crunching. And so coming back to this again, why do we care? Well, we in particular care basically for these two reasons. For cost, like I already showed you on our cloud bill, and for throughput reasons. It makes a big difference if we can send a terabyte within a couple of seconds versus minutes, right? That's huge for us. But I'm going to primarily focus on the cost aspect today. If we want to, maybe we can do more talks about why throughput is really important in our system. So, what is the rule for doing any kind of improvement? We've got to measure first. And so that's kind of where we started. We saw this cloud bill. We knew, because the cloud bill was telling us, this is where the cost was coming from. We needed to understand, what is our cloud provider giving us other than the bill that, at best gives us the breakdown per day. Obviously, that's not the kind of speed at which we want to iterate at, nor does it really tell us very much about what exactly in our infrastructure is causing this. So turns out GCP doesn't give us anything to help with this. So we kind of turned one layer lower, which is our networking provider on Kubernetes. We happen to use what Google Cloud calls the data plane v2, which is essentially Cilium with a couple of patches. We have some isovalent folks here. Correct me if I'm wrong. with with a bunch of stuff removed. However, after talking to a bunch of these folks that work on Cilium, it turns out it's not super trivial to implement this in the first place. It's unclear whether this is ever going to land, or whether the kind of granularity that we want is actually ever going to be possible in Cilium. And even then, it's unclear whether it might even be able to land in kind of GKE's fork, because if it lands in the enterprise version, which makes sense, right? This is a really advanced feature. If I was isovalent, I would want to charge for that as well. But bottom line is, it didn't seem like we were going to get access to this anytime soon. And so really, really the only option that we had was for us to build this ourselves. So, and that is how this project KubeSonnet, that I named KubeSonnet, was born. So what is KubeSonnet? At the kind of from a high level perspective, what it does is it monitors all of the network packets that are routed through our hosts, and then figures out which one of those packets has crossed a zone boundary versus which one was just moving within the same zone. It then aggregates all of that and exposes it as Prometheus metrics once, and then what I quote the flow logs, because if people know what flow logs are, this is like an abomination of that. But it gave us just about what we needed in order to do what we needed to do. Quick heads up, at least the way the project is today, and we can talk. I'll talk about this later a little bit. It does, of course, I've already mentioned this, require Cilium to be the CNI. It also requires Cilium to be in what's called legacy networking mode. We'll talk about later what that means and why that's necessary. Long story short, all GKE data plane v2 clusters are in legacy networking mode. So if that's what you're using, then you can use this. You need a Linux 6.4 kernel or newer. Again, we'll talk about why this is necessary. And because our clusters are IPv6 only, that's where we stopped. If you care about IPv6, please contribute. So how does it actually work? I talked about it from a pretty high level perspective. So we use something called eBPF. Who's familiar with eBPF? Okay, cool. Then I'm going to give a very quick intro. So basically, what's really cool about eBPF is it's this virtual machine within the Linux kernel that we can use to extend some of the functionality within the Linux kernel without kernel modules and so on. And it ensures that the programs that we're going to be running are safe to run. And if they do try to do something that they shouldn't, it immediately stops execution for those. So for the type of thing that we want to do, this is really interesting because we can grab data at a very specific point in time in the kind of networking stack that is most useful to us, right? And we can then kind of gather all of the statistics that we need and then do all of the interesting things with it. So that's kind of the very high level overview of eBPF and the way that you kind of communicate between an eBPF program, which, like I just said, runs in kernel space, with a user space program, is through something called eBPF maps. And so what happens is that the eBPF program finds all the data that it wants and then kind of either sends it off directly to be collected by the user space program, or it can kind of increment a counter in a map, for example, in this particular case. And then the user space agent can go and say, okay, I want to read everything or a specific key in this map. And therefore, that's kind of the way that then the user space program can communicate with the kernel space program. So hopefully that makes that a little bit clearer. I have a little bit of code. I don't know how much that's readable from the back. Give me a yes, no?
Yes, no, maybe.
Okay. Okay, actually, let me just, I have this code open over here as well. So can make this even bigger than the. So I mentioned NetFilter already. So basically, I'm actually not a networking expert at all. We've got some folks that are over here, but vaguely speaking, NetFilter allows us, especially the post-routing hook. This is basically me telling the system, this is the type of hook that I want my eBPF program to be run on. So after it has been decided how this packet is going to be routed, this function is being called with some context, and that's all we got. Then we need to figure out what is the useful thing that we want to do with this piece of information. So basically, the most important parts here are, we want to figure out, okay, what kind of IP version are we dealing with? So in this case, it's IPv4, and so as you can see already, I just didn't care about IPv6 here. This is contributions, welcome. So I just implemented the handle IPv4 function, which also isn't particularly large. Basically, all we do is we allocate a small buffer that is enough to read the IP header, because really all we want is to figure out what is the size of the packet, right? And the next thing we do is just some subnet matching. So is this packet source? Do I remember that right? Yeah, is the source and the destination actually within the subnets that we care about. But because really all we cared about with this project is are the network packets that are being transferred happening within the pod network on Kubernetes, right? So we're filtering only to things that happen within the pod network. And if that happens, then we figure out what is the source IP, what is the destination IP. We store the packet size, and then, like I said, we either if this combination of source and destination IP has already been seen before, we just increment that value in the BPF map, and if not, it's just a new element that we're adding. So really, this is all there is to this eBPF program. At the start, most of it is just kind of includes and definitions and struct definitions. So, just how we're laying out the data, not really that complicated or important. This is really the meat of this program. It's really not that complicated. And so then what we can look at is the user space side, which is over here. The way this works is, and the Cilium folks actually built a really cool library for Go for this that makes a lot of dealing with this much, much easier. Actually, let's pull that up real quick. Here we go. So basically, you just add this Go generate. Obviously, this is written in Go. Command, I'm not exactly sure. Annotation, I'm not sure what to call this. But the Cilium folks have written this BPF2Go project. And so all this does is it compiles, it handles the compilation of the C program to the appropriate target and so on, and then generates some boilerplate, which is what we see here in the in these files. And so basically, that's a long way of saying this generates a bunch of nice structs and functions and everything for us to just not have to worry about how does all of this wiring up work. We can just kind of consume it after writing our BPF program. And then, because we have this wonderful library from the Cilium folks, we can just say, okay, I want to attach my program that I've previously loaded. That is called NF post routing hook. That's the function that we saw in our BPF program, right? And I care about IPv4, and for whatever reason, the post routing hook number is 4. Probably, there are some other ones that 0, 1, 2, 3 stand for. And then, again, what's pretty simple about this is all there is to it is a for loop that runs indefinitely for some flush interval that we see over here, which is just a flag on the binary. So every 10 seconds by default, we gather all of the network statistics that have been gathered thus far, and then send it off to a central server. The server is significantly more complicated, so we're not going to be walking through the code there, but we can skip straight ahead. So at the end of what I just showed you, really all that happens is the agent, for all of the network packets that happen within the pod network, sends the source IP and the destination IP, as well as the amount of bytes that have been transferred to this server component. So again, so far we've only looked at the agent. So what does the server then do? This is very simply put. Again, this is the larger part of the project. But essentially what it does is it figures out, OK, this is the source IP, this is the destination IP. Which pods does this belong to? So then we figure out, OK, these are the two pods that are communicating here. Then we take that pod information and figure out, OK, which node is this pod running on? And then ultimately, because really what we care about here is, has the zone boundary been crossed? Then we figure out which zone is the node in that the pod is on. And so then finally we can figure out, OK, these two pods, were they on in different zones? And if that was the case, then the server saves that and then and logs it, as well as then saves it to be exposed on the Prometheus endpoints. So a couple of things that were a little bit surprising. So the first time we actually put this in production, we saw something kind of unexpected, which was we saw a bunch of double accounting. So there was way more network traffic being reported than was actually happening, right? And the reason for this, once you think about it, is actually very clear. Post routing is called several times on multiple nodes, on the source node as well as the destination node, right? And so naturally, we accidentally double accounted for all of this network traffic. The difficult part about this was it wasn't always happening, right? Because sometimes the traffic was just happening from within the same node. And so that made troubleshooting that a little bit confusing. Something that we haven't actually figured out yet, again, great contribution if you want to get your hands wet with eBPF. And we didn't really care about this because really all that mattered to us was which components, which pods kind of percentage-wise are causing the most cross-zone network traffic. For some reason, we could never figure out how to read the full Ethernet packet size. For some reason, the verifier isn't happy with us reading that. By the way, the verifier is one of the components that makes it safe for BPF programs to be run in kernel space. So we went with the next best thing. As you saw in the code earlier, we're just using the size of the IP header. The size that the IP header says the rest of the message is. We're only a few bytes off, which is still good enough for our purpose of saying, OK, which pods are the biggest offenders. Then another one that was kind of funky was dealing with network order versus host order. Specifically when we wanted to do the subnet matching, right? Because we really only care about the traffic that was happening within the pod network. In case you didn't know this, what network order versus host order is, so maybe the network folks can correct me if I get this wrong. I believe network order is little endian, and host order, well, depends on your host. Is that correct? OK. Well, that's kind of important, right? Because if we're then sending this data onwards and we're interpreting it, we're interpreting a little endian number as a big endian number, well, then it's all garbage. And then the last but not least net filter ordering is actually really important. And this is precisely the reason why we only support, or one of the reasons why we only support legacy networking mode in Cilium. So one, net filter routing, net filter eBPF programs, because Cilium also uses net filter for a variety of purposes, or can use net filter for a variety of purposes. It may matter in which order these net filter programs gets executed, because it may end up deciding that this, this packet is not being routed at all or something. And so that's kind of tricky as well. And then there's, I believe, the non-legacy networking mode in Cilium, I think, kind of circumvents net filter altogether. And so obviously then this kind of thing doesn't work. So I'll get back to kind of things that we can do about that. But the cool thing is now we've got Prometheus metrics. So this is a little bit small, but what we're seeing here is the top 20 pods across the entire infrastructure by the amount of megabytes per second that they've sent per second. So here we can see one pretty big offender, for example, that was transferring over 100 megabytes per second. And then it kind of ends up going down pretty quickly. But this was super helpful. And then down here, it's like 10 megabytes per second. So all of this certainly doesn't matter anymore. But the big ones, they kind of matter. And so this is really interesting because now we could say, okay, it's these kinds of pods that are causing this problem. And so what does this thing do? And therefore, we could make some decisions of how to improve this. Like I said, these are our flow logs. At the end of the day, these are just the source pod, the destination pod, as well as the amount of bytes that were sent. No standard format or anything. Again, this was good enough for us. It did the job for us, so that's kind of where we stopped. If anybody wants to implement, a specific flow log format implementation, by all means, happy to accept contributions for that. But again, here, this was really interesting because what we're seeing here is our CockroachDB cluster, and the lower two numbers, they're not surprising at all, right? It's the different participants of the cockroach cluster communicating with each other. Perfectly normal, right? We totally expect that to happen. However, this was pretty difficult to see previously because we didn't know what was causing all of this network traffic to or from the database. And so now, finally, we could see, it's not at all the cockroach nodes talking to each other. It's actually this very surprising workload that is causing all of this. And it turns out this was just doing network transfer, like SQL queries against the cockroach cluster in like a hot loop for no reason whatsoever. And so it was super obvious that that was the offending workload. Why was it talking to the cockroach cluster in the first place? We were lucky. There was really only one place in the entire code base why that component was doing that. And so it became very, very obvious very quickly. So what, I talked about one very specific example. I'm going to talk about one more thing that made a really big difference. But basically, if we remember, what was this is now this. So we more than halved all of the cross-zone traffic already with just basically two very small changes. The one that I just talked about. And then the other one is our monitoring system that is largely comprised of a set of Prometheus servers. But the offending thing was actually our query infrastructure where, I don't know if people are familiar with the Thanos project. Basically, it's a distributed version of Prometheus that can store all of the data in object storage. And the really problematic thing we figured out was not at all kind of the transfer from object storage into the cluster. It was actually when we were processing all of the data during query time. So when it was actually already in cache, but the courier kept hitting cache, and so there was a lot of transfer between the cache and the query infrastructure. And this was happening all of the time because, well, we're evaluating our alerting rules all the time, right? And the solution to this, while a little bit involved, really wasn't all that complicated. All we did was force a deployment of Tanos in each zone. And so therefore, the entire query infrastructure would never leave the zone as it was querying, right? And so, as we just saw, that made a pretty huge impact. And then the small bit that we're kind of seeing to be left is something we're not quite ready to talk about. But when we have, when we've solved that as well, we'll definitely be blogging about this bit quite a lot as well. So with that, kind of starting to wrap up, what's on the roadmap for this project? So the first thing, kind of obviously, again, we really were just solving a problem here for us. So we stopped more or less at the point where it did solve the problem for us. But we've heard from several companies already that they obviously would like to be using this with different modes of Cilium or a completely different CNI provider altogether. And it turns out, chatting with some folks on the eBPF Slack, there are actually other hooks that we could use that will make this work that aren't NetFilter specific at all. Particularly because all we really care about are containers, and the containers that are managed by Kubernetes. And there are hooks specific to C group networking that are called all the time. And so hopefully, when we find a day or so to implement it, it should actually be possible to run this project against just about any Kubernetes cluster out there, provided that you're actually using a container runtime and not something sort of esoteric like virtual machines being managed by Kubernetes. Of course, we would love IPv6 support, as well as actually accounting for the full Ethernet frame and not just the IP, the bytes that make up the IP package. And then, again, I think this is something, especially for extremely huge clusters, this is going to be really interesting because we currently expose Prometheus metrics on a per pod basis. That's not really all that useful, especially because we have the flow logs that really tell us exactly which communication took place. And so really all we've been looking for whenever we looked at these metrics was which workloads are the biggest offenders. So really all we need are which deployment was this, which stateful set was this, and so on. I think that would drive down the cardinality quite a lot while actually maintaining exactly the same usefulness of this project. So if any of that sounds interesting, again, contributions very much welcome. Couple of shout outs. We actually have Casey in the audience here today. So a bunch of people helped me understand this space, especially as I was navigating kind of, do I really have to build this myself? Can you all people please do it for me? So a bunch of the Cilium folks were super helpful in understanding what can Cilium do today, what would be the right hooks, figuring out all of the issues that I mentioned, and then help me kind of put mentally together how this project could ultimately work. So thank you to all these folks. So now you as well have the power to get a hold on your cross-zone traffic, should it be a problem for cost, for throughput, or for latency reasons. Thank you. About 10 minutes too fast. Any questions? Yes.
I would be interested, first of all, cool presentation, cool
Thank you.
project. I would be interested if you checked if the sum of the bytes or the sum of the network traffic you are logging is basically the same as the one that the cloud provider then bills you for. So if you could verify it, or is it very near, since you said you made some
Yeah, great question. So the question was, did we compare essentially what the cloud provider gives us at the very high level with these really fine-grained metrics that we're gathering? And yes, definitely. So when we saw, about a 50% reduction in the cross-zone traffic in the metrics, we saw exactly that materialize on the cloud bill. So yeah, definitely, at least ratio-wise, it checks out. Go ahead.
I was finding myself in a similar situation, and for that, actually, I took co-root,
Uh-huh.
which actually gave me quite similar and actually much more data, not only kind of throughput between workloads, but also kind of actually requests and packets per minute and stuff like that, which was actually also helping me detect. For example, we were running on AWS, and we actually used swap instances a lot.
Yeah, same.
Quite often, the case was that the latency between certain nodes was really big,
Yeah.
even though they were in the same zone. So we actually also detected kind of, okay, these kind of nodes we should not get anymore. So also kind of made quite some, or shaped our decision making in the process for autoscaling and similar situations. And I know that code also uses eBPF internally. Did you actually took a look into it, please?
Great that you bring it up. I wish I had talked to you before I started this project. So just for the purpose of the recording, this person mentioned that there's a project called co-root that also uses eBPF that gives even higher detail information. Does it also give you the zone information?
I don't think directly, but it gives you also access to the labels. So you actually see once the labels are set correctly, you can actually see it.
Got it. So just for the recording one more time. So it does give you not the zone information directly, but through labels, and I guess like Prometheus joins, you can then figure out what the zone is, or how does it work?
I just use it barely, kind of what it gives me.
Got it.
Directly. Yeah.
Okay, cool. Also check out co-root. Any other questions? Yeah, go ahead.
Actually, I was thinking about it, just combining things, right? And I'm not sure where you actually want to go with this kind of project long run, because I was just thinking, hey, if you actually collect certain data, and don't stop at looking at the zones, but also like nodes and whatever, you could actually easily kind of auto detect. So first of all, relationships between workloads. And then, of course, also, for example, try to bring in a bit of chaos and move workloads around to see how behavior changes. And by that, step by step, find kind of best correlations, both in terms of costs results,
Yeah.
but also for latencies, high throughput, and whatnot.
Yeah, makes sense.
Like a fully automatic system.
Yeah. I mean, especially in terms of metadata, I see no reason why we wouldn't attach more metadata to all this information. Again, we kind of stopped at the point where it was enough for us to solve our cost problem. But certainly, I said at the very beginning, there are several reasons why cross-zone traffic matters. And really, we only solved, for us, the cost problem. We didn't really solve or think about the latency problem or even the throughput problem at all either. I will say, at least for us, it doesn't really matter that much because we just try to keep all traffic within the same zone now anyways. Also with our main product, which you can probably think of, the last half that's remaining is essentially the whole data flowing through our product. And there it definitely makes a huge difference, both in terms of latency as well as in throughput. So I can imagine us adding a ton more metadata to this, both to the flow logs as well as to the metrics to be able to understand all of these things exactly. Yeah, I can definitely see that. All right, thank you. Only 5 minutes short.
All right, let's give people a minute to sit down again, and then we're going to start with the second one. All right, we're going to go on? Perfect. Yeah, also, thank you very much for being here from my side. It's an amazing crowd. Way more than I expected to show up. It's really awesome. Thank you very much. Before we start, the first thing I learned when I gave this presentation for the first time was that people completely misread this picture. They read it as do Postgres, don't do Kubernetes. This is not what we're here to talk about, right? This is not what it is. It's the do's and don'ts to run Postgres on Kubernetes. That was not made up. It's actually the first question that I was asked. Anyway, so why is that not changing? Hey, there you go. That's what it should be. Well, whatever. So as I said, Postgres and Kubernetes are big friends. So I think it's a good match, and I'm here to talk about why I think. And if you want to run Postgres on Kubernetes, what you actually have to do. Postgres users in the room? All right, I expected you. Otherwise, I would be very, very mad. Postgres on Kubernetes? No way. OK, I heard it already. No way. All right, all right. I see I have to do some convincing here. That is so funny. It does not change the screen. What? All right, seems I have to do this every single time. So that is me. I'm a dev for Simpleblock. I think you already heard this from Rob earlier. I've been with some interesting and fun companies in the past. The most common or most known one is probably Ubisoft. If you're a gamer, you hate them for all the copy protection they did in the late 90s, early 2000s stuff. That was not my time. I was actually there afterwards. But I've been at Instana. We were eventually acquired by IBM. We did observability. Had my own startup for a little while. I was at Timescale, which is a time series extension for Postgres. Timescale users? OK. Why are you going to have your hand up? All right, at least a few people. Timescale, is it good? Is it bad? Good, perfect. OK, so it seems like we did our job. And oh, OK, whew, it works now. So does anyone know that? In German, it's Familienduell, just for the people that do not know that. The idea is basically people walk around, I don't know, the city, ask 100 random people a question, and collect the answers. And you get points if you can guess the right answer. So that's basically what I did, right? Why shouldn't you run a database in Kubernetes? And because I did not walk around the city, right? That's weird. I mean, we're IT people. We don't like other people, and we actually don't like to talk to people. I actually went to Twitter. All right, I went to Twitter. There we go. Sorry, X by now. So why shouldn't you run a database in Kubernetes? What do you think? Please help me. I need you. And I hope this works. Yes. So the important thing is, if you ask a controversial thing on social media, ask for a friend, right? That's the important thing. It's never about you. What is going on here? So the answers were kind of simple. Why shouldn't you run a database in Kubernetes? The first one is Kubernetes is not designed with databases in mind. I agree with that. If your mind is like 10 years back, that's totally true. If you start thinking about it like 5 years ago, well, it might have changed, right? That will be a fun presentation, I think. Let's just do it that way. I don't care anymore. Let's hide that thing. We're just doing it that way. So we're doing the fancy thing. You never should run any stateful workload in Kubernetes at all, right? Because you just shouldn't. Anyone running stateful workloads in Kubernetes? Oh, perfect. Thank you. Thank you. So is that a valid thing? No. Persistent data will kill you. It's way too slow. Take the right product, and it is not true. We'll get to that. As you heard, we're a storage solution. Nobody understands Kubernetes. That's actually my favorite one of all of those, and it's probably true as well, right? Even all of the developers working and contributing to Kubernetes, I'm pretty sure they don't get half of the other stuff that people contributed. But if that is like your main reason not to run a database on Kubernetes, please don't run anything on Kubernetes, right? You just don't do this. Like, don't even run your microservice on Kubernetes. It's not going to work out. What's the benefit of what's the benefit? Databases don't need scaling. I'm not sure if I agree with that. Who runs a database and has the feeling that you might want to scale out, or you had to scale out or scale up at a certain point in time? OK, seems like we have some people that actually run meaningful databases. That's good. Databases and applications should be separated. I completely agree with that. And we get to how to do that in Kubernetes, because guess what? There's node pools. Ooh, magic. And that is another one I actually agree with. Not another layer of indirection abstraction. Who likes abstractions? Who likes abstractions when something goes wrong? Exactly, right? That is the love-hate relationship we have. We love abstractions because they make things easier, and we hate abstraction because they make things hidden when something happens, right? So, OK, so I looked at the answers, and that were actually real answers I got on the poll. Not necessarily in the order, but very close. So I looked at that, and I was like, OK, I wanted to talk to people and explain why I think Postgres and Kubernetes is a good thing. So what do I do now, right? Do I have to burn in hell now before I even give the presentation? Because where we wanted to go is that, right? The happy place. And you're not getting all the cool animations, so just assume the animations for the memes being around, right? My idea was like, we need to cheat. OK? So we need to cheat something together. Who knows what that is? The Konami code. Perfect, the Konami code. For other people who don't know what the Konami code is, please know, please. OK, the Konami code is the best cheat code ever. It was created by Konami somewhere in the early 90s. It showed up in every Konami game. And it was so popular that even other studios started to use it in their own games. Most of the time, it gave you like God mode. So we're on God mode, basically, right? So the question is, why would you actually do that? And I already heard, like, never. I'm not going to do this ever, right? So why would you do that? The main point for me is that there is no vendor lock-in, right? Vendor lock-in in the sense of, if you run a database somewhere else, or you use one of the nice cloud-hosted databases, guess what? You're some kind of vendor lock-in. None of the databases, no matter if it's RDS, if it's Aurora, if it's Google Cloud SQL, or any of the other ones, including things like Gigabyte and stuff, they're not 100% compatible with Postgres because we're all doing changes. Meaning, your query that is perfectly fine on your test system running standard Postgres might be very different on Aurora. And you would only figure that out in production. Don't think it's a good idea, right? Faster time to market. I think that's a common or like an obvious thing, right? If I have the Kubernetes cluster, it's easy to deploy. I can just drop it in, and it's good to go. It decreases cost because I can share the same infrastructure. Yes, that is true for virtual machines. Don't tell me. Automation, I think that's obvious. That's all what Kubernetes is about, all of the orchestration stuff. I like the unified deployment architecture because I think deployments are already way too complicated. So if I can focus on one specific deployment style or deployment architecture, that I think is really good. And if you really need read replicas, or you like read replicas for just dynamic read replicas for reporting or stuff, Kubernetes is a really nice thing because it literally just gives you the option. Like, you scale up, you get another read replica. You can say, don't put this into like the standard distribution. You get a new IP address, and you're good to go. So before we go into the nitty-gritty of like how to actually do Postgres on Kubernetes, I think there is a few important things Postgres general that we need to get out of the way. There is something, that everyone needs to remember, and now I wonder how many people do actually do this. Who has TLS enabled in Postgres? Who knows that there is TLS enabled in Postgres? Okay, it's at least a few people. Kubernetes secrets, or some secret generating service like HashiCorp Vault or anything, creating credentials, perfect. So at least some people. Cert manager to automatically deploy the, okay, perfect. I see people nodding. Encryption at rest. Okay, well, that's at least 4 or 5 hands. That's good. From like, how many people ran Postgres? Right? That's not a Kubernetes thing. If you're running a database and you have just barely private information, make sure you have encryption at rest, or you're actually encrypting data before you store it in the database, but nobody does that, right? We all want to encryption at rest. So yay, okay. Backup and recovery. Okay, I see at least one hand. Let's see how we get here, right? Continuous backup and point-in-time recovery. Okay, one hand still. Not rolling your own backup solution. Not using PG backup, but PG backrest or whatever you can use outside of Kubernetes as well. What kind of backup solution are you using? Okay, perfect. So no PG backup, base backup, good. So, well, okay, perfect. The important thing is just don't take PG base backup or PG dump and assume that to be a valid backup. PG dump has its own problems. It kind of works, but only kind of, right? Use tools like PG backrest, Barman, PG Hort, Valdi, or whatever. And if you have a backup, send it somewhere. Don't store it on the same machine. Don't store it in the same cluster. Don't store it in the same data center. It's not a good idea, right? Send it to, if you're in AWS, you can send it to S3. If you're on-prem, send it to a different data center if you have an offsite backup. If you don't have an offsite backup, get one. It's not only for your database, but for everything. Just get an offsite backup. So in general, who runs backups of the database? Doesn't have to be Postgres. Just, OK. How often do you test that? Exactly, right? So that is actually a real problem. Like, people are laughing. Like, when you ask, like, how often do you test that? Did anyone in the room fail to restore a backup in the past? OK, I shouldn't have asked that. All right, so here is one interesting fact, right? I said I ran my own startup, and we actually ran timescale and Postgres and stuff like that. And the way we did it, because we were in Kubernetes, is that literally every, I think it was Tuesday or Wednesday, we killed one machine all the way, including the storage and everything, and we let a new pod be created, a new persistent volume. We had the backup being replayed. We had the node join the cluster, get up the replication stream, get up to speed, and finally get into replicate or into distribution. That meant literally every week we had a node replaying the backup, and we knew it just worked. If it didn't, we had to look into that. It didn't happen for us, but we were lucky to know, or we were good to know that it actually worked, right? So yeah, test your backup. I cannot emphasize that enough. Postgres configuration, it's actually kind of interesting. From my experience, there is not a lot of stuff which is super, super Kubernetes specific. There are a few things, and you want to be careful about those. But in general, there's not like super or a lot of influence. What you want to do is you want to configure the stuff that you always configure. If you do not feel like you want to configure Postgres and the 1,000,001 Postgres properties and configuration issues and stuff like that, get somebody to help you. I'm not sure, are there Java developers here or Java folks? Nope. OK, partly. The JVM has 1,000,001 options on how to configure it, the garbage collectors and all that kind of stuff. Postgres isn't better. If you look at the Postgres configuration, there's the same thing. It's so many parameters, and they all influence each other. If you don't feel like I know exactly what I'm doing, get help. There's people that do this 24/7, at least it feels like. But what you want to look into is like shared buffers and workmam and all that kind of stuff. Just make sure that if you're running on a container, in a virtual machine, or anything, even like a dedicated host, make sure that you actually configure those according to memory sizes. And use huge pages. Like every database, every virtual machine, whatever, everyone likes huge pages. It takes a lot of memory management overhead away, not only from the application, but also from the operating system. Use them. That is specifically the thing you really have to be careful about when looking into Kubernetes, and we're going to look into that in a few. There's much more knowledgeable people than me talking about that stuff, so we're going to share these slides afterwards. You don't have to take a picture of that. But there's people just looking into that kind of stuff specifically. For the ones that are running on Postgres, who uses extensions? I thought so, right? Was there anyone using Postgres where is like no extension in use? No, OK. Exactly, right? That's what Postgres is, right? Postgres is super extensible, and we want that. So we want extensions, and there's good extensions. There's a lot of them. Timescale is just one of them, but there's PG vector. There is PG stat statements. There is so much stuff on Postgres just to extend either like the language or like the SQL language, adding additional functionality, adding different data models. I mean, you can use a Postgres database and store your standard relational data next to a key value store, next to a graph database, next to a time series database, next to, did I miss anything? Huh? Yes, column store, geospatial information, PostGIS. You can basically build your whole system in just one Postgres instance. Don't do this, but you can, right? It's cool for a presentation. The problem is most of the extensions aren't part of container images. On dedicated hosts, it's not much of a problem because I go into like apt-get or like RPM or whatever and say just install it. On container images, it's a little bit more complicated. So in this case, you actually have to build your own layer, and building Docker images or image layers isn't super fun. Especially, I'm not sure if is anyone here working for a company that has to certify image layers? Oh, OK. OK, four people. I just wanted to say you're all lucky. But yeah, so it's a real issue, right? Depending on what company you're working for, like insurances, government, anything like that, they often have to certify everything they put into production. Now imagine you have to build your own image layer every single time, right? And there is some magic option. We're going to get into that later. And I think the last one is actually keep an eye on your PG and Kubernetes versions. Kubernetes is specific, but keep an eye on a Postgres version. You don't want to run a Postgres version which is like 4 major versions back. I know there's still people having Postgres 9.6 in production, but it's not a good idea. Don't do this. There's so much development in the Postgres space, you really don't want to do this. Same thing for Kubernetes. My personal favorite is normally the cloud providers, if you use like a hosted Kubernetes, they support like the last 3 or 4 versions. And then you're off your own. Most of the time, they don't even give you the chance to go further or further back. They just upgrade you, like randomly. Great idea. That's exactly what you want, right? You have the cloud provider going ahead and like, oh, you know what? You're on a too old version. I don't care for your business. Let's do the upgrade right now. I'm like, what? No, right? AWS even had a better idea. Who knows what AWS introduced last year? Nobody? Extended Kubernetes support. 3 more versions for 10 times the price. So if you go beyond the 3 supported versions or 4 supported versions, you're actually paying 10x now for your Kubernetes cluster. That's a great deal, right? For that money, you might want to hire a DevOps person or somebody just making sure that your Kubernetes cluster is always on par with whatever the latest or almost latest version is. Don't always be bleeding edge, right? With that out of the way, what is really important or what is really different? And there are a few things. First of all, you all heard we're a storage company. So I had to start with that, and I think it's also the most obvious one, right? If you're on a dedicated host or if you're on a virtual machine, storage is fairly simple, right? You get your virtual block device and whoo, we're good. In containers, it kind of looks like a little bit different, right? So you have the broken dreams of your storage lockers kind of thing. In Kubernetes, you use persistent volumes. A persistent volume is basically, first and foremost, some magic thing that has a file system on it. However it is created, it might be an NFS share underneath, you don't know. You just wonder about the bad speed. It might be a local volume, like a locally available directory basically being merged. That's nice if you have SSD or NVMe attached. It might be a remotely attached block volume. It might be, FSX, basically a remote file system. It could be anything. From a Kubernetes side, it all looks the same thing. The only difference is if you have a block storage underneath, you can say, hey, I want a raw block storage device. Otherwise, you get some file system on top, normally like ext4 or something. From my perspective, local volumes, by the way, are a really bad idea because you get no safety guarantee. If you really run a database and you use local storage and your Kubernetes physical host goes away, so goes your data storage. Not the best option, maybe, right? But it should be provisioned dynamically, meaning you do not have to go in manually creating the volume first and then say, hey, in my Kubernetes deployment for that specific database, I want to use this manually created volume. But you basically say, hey, I want a 100 gig volume, and Kubernetes magically, or the storage provider magically makes that happen. However it works, right? OK. There are CSI providers. CSI is the container storage interface, basically Kubernetes way to talk to external plugins managing storage. And everyone supporting storage for Kubernetes will basically implement the CSI interface and provide that. If you select a CSI provider, make sure it supports encryption at rest. You remember, you really want to do this. It's not always a thing. If you use an NFS share, there is literally no way to do encryption at rest, except for the storage server that somehow exports this NFS share might do it, but you don't know, right? You just don't know. For databases, we really want a lot of IOPS, except for you're running the databases that really don't care if they die, and you don't need to scale out your database, right? If you don't need to scale your database, don't care. Otherwise, databases love IOPS, like I/O operations per second. The more, the better. The more, the merrier. They love low latency. And in general, your database loves everything that brings performance, right? The more storage I can read or write, the better. The lower latency it is, the better. So with that, there is one problem. That's a lot of different things you have to think about. Oh, right. We're getting back to that in a second. And it's not always easy because there is, like 150-ish CSI drivers by now. Just finding the right one for you isn't super easy, I think. Right? There's a lot of things, and not everyone supports everything. You see file storage, object storage, tracking, change tracking, and stuff like that. For that reason, a while ago, and I need to update it, I actually created storage class info, trying to list every single CSI driver that I could find, which is not easy because there is no, the documentations of CSI drivers aren't always super helpful in terms of what features are supported. So the way you do this is you look into the source code and try to figure out what feature flags are enabled. Yay, yay me, right? With 150, that was not a lot of fun weekend. Or I think it was 2 weekends. But it should give you like good hints. If you can search by capabilities, lifecycle modes, all that kind of stuff. As I said, I need to update it. If you find anything, if you're working for a competitor and you find anything that is wrong, let me know. It's on GitHub. You can send a pull request, fix it. Great. I think this should be very, very much what it is, right? Right, and as I said, we're coming back to that. I would recommend using a disaggregated storage. Who knows the difference between disaggregated and, or who does not know the difference between disaggregated and hyperconverged? OK, there's at least 4 hands. OK, so disaggregate, in a Kubernetes world, disaggregated means or like in general for storage, disaggregated means it's somewhere separate, right? So you have a storage cluster somewhere apart from the rest of it. Whereas hyperconverged, or a better term would be co-located, means that your storage and your workload is actually on the same machine somehow. If your Kubernetes worker nodes have NVMe attached, for example, you can just use that NVMe and offer it as volumes. For hyperconverged systems, normally you get either replication or some kind of other magic to make sure that the data is not lost when the node is lost, which is important. It's not the same thing as just using the local storage for your system, right? OK, we have that. For Kubernetes specific, or specifically, there is requests, limits, and quotas. And I will not claim that I've ever understood how this worked. You remember, nobody understands Kubernetes. That is one of the things, and I cannot tell you exactly what the difference is between a limit and a request. I kind of get the feeling I know what it is, but it's complicated.
I'll tell you all about it later if you want.
You tell me all about it later. You can tell. Here's a micro. No, it's fine. We can talk about it. So the idea is basically, I think, and correct me if I'm wrong, I think requests are basically what you expect the database or the application, the pod, whatever, to use, whereas limits is like the hard limit. If you go above that, you're going to be killed off. That's my understanding.
Request is for autoscaler. The limit is for killing.
Oh, there you go. OK, request is for autoscaling. Limits is for killing. Scheduling. Oh, OK. All right, all right. All right. All right, there you go. I learned something. Good day. I wanted to end with a quote that there's people that are knowledgeable, because there's also another couple of links. But you should use them if you try to understand what they mean. Normally, I kind of said request and limit the same thing, which I guess is not correct now. So don't do this. Ask what you actually should do.
That just guarantees quality of service, which does make a difference.
OK, perfect. OK, so you're saying it's the right choice. All right. The important thing is you want to be kind of precise. And if you're running meaningful databases, the databases that actually have to scale and stuff, try to prevent too much contention, because you want to ensure predictable latency. I go into that a little bit later, because I would actually not recommend sharing the same nodes for your database and other workloads, again, if you're running a meaningful database. As I said, there's other people writing about that, so there's stuff to figure it out. Huge pages, you remember we talked about that? Yes, you really want to enable huge pages. The problem is you have to do it twice. Actually, well, kind of 2.5 times. You have to tell the operating system you want to use huge pages, and please tell the operating system to reserve a chunk of memory for huge pages. Otherwise, you get this like weirdly distributed, possibly fragmented huge pages kind of stuff. And then you have to give it in the resource descriptor to make sure that it's actually available in your Kubernetes a container or a pod, because otherwise everyone could use it, right? So that's the important thing. You have to configure it twice. There is a great example on how to do this in Postgres. It's a major, major difference. What is Bixby always telling you?
One comment on huge pages.
Yes.
Be careful about newness.
Yes. OK. Good point. For the recording, if you're using huge pages, you want to be careful about NUMA nodes. It's not the only thing you want when you want to be careful about NUMA nodes. NUMA sucks. It's great, but it sucks. For the ones that don't know what NUMA is, read on it, and you know what I'm saying, why I'm saying I hate it. And I love it at the same time. Resilience and overhead, just super important. We want high availability, right? We're running a production database. If you're not running a production database, just close your eyes right now. Nobody cares, right? There's great tools in a Postgres ecosystem, not specific to Postgres, but to Kubernetes. But in general, from my perspective, I think Patroni is like the most commonly used cluster manager. It's created by, I think it's a Berlin-based company called Zalando or something. Never heard of those guys, right? What is Zalando doing? Shoes, exactly. Shoes and clothes. And it seems like they're also doing Postgres. Quite a lot of it. I think the whole database infrastructure at Zalando is actually Postgres. So they're like 100% Postgres shop as far as I know. But there is Rep Manager, there's PG out of failover. There's a lot of stuff. But use something like that. Don't try to build your own, OK? There's another link. And then there is connection pooling. Who used Postgres? OK. Who uses Postgres with connection pooling? OK. Was there anyone not having a hand up for both questions? Because you should leave the room right now. Connection pooling is not an if question or when question. It's Postgres, yes. The question is connection pooling, question mark, yes. Right? Because connection pooling or Postgres should never be used without connection pooling. For the ones that actually use Postgres, they know that Postgres really doesn't like the idea of connections being opened and closed all the time. Like the connection process is really, really expensive. It has a lot of overhead, and the resource utilization will literally just kill you. A connection pooler sits in between. Does everyone know what a connection pool is? Yeah? Somebody not? OK, so I don't have to explain it, right? It sits in between the connection, blah, 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 and make sure that you're basically sharing the same backend connections over and over again. It also does some kind of nice features. It automatically handles failover, depending on what kind of stuff you use. It handles switching primaries together with things like Patroni and stuff. And from my perspective, it's super nice together with read replicas, because if you do not have the issue, and there are use cases where you have the issue, if you do not care for a very small replication lag between the primary and the secondaries, that's a great way to scale out your query performance. For my own startup, we collected measurement data from animal barns, basically ammonia, CO2, blah, 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 all the kind of stuff. We got values like every few seconds, but we basically calculated like an average over an hour stuff. We didn't care if there's the replication lag of like, let's make it horribly, right? Oh, the replication lag of a second. We just didn't care. So what we did is we just sent all of our queries, all of our analytical queries, to all of the nodes we had, no matter if it was a primary or secondary. And that is great, because connection poolers can handle that for you automatically. There's one thing you really have to be careful about when you do that. So what they do is basically they figure out if something is a mutating operation. So if you do an insert or an update, that's obvious. If you do a select, they most of the time assume it's not mutating, so they might just send it to a read replica, which in case for something like timescale might actually be a really bad idea, because timescale has some functions doing some magic, like create hypertable, basically taking a table and transforming it into the timescale equivalent. That is actually mutating, but because it's selected, those things normally tend to assume it's a non-mutating operation, so they are like, oh, cool, I sent this to read replica number 5. And now your system runs completely out of place, and you get all weird things. They all have some, it's not whitelisting. What is the actual term now? Huh? Yes, allow list, thank you. They have some block list and allow list to tell you exactly what functions might be a problem, to say, hey, this function is mutating even though it doesn't look like, so please send it to the primary, always, right? Apart from that, we're in the Postgres ecosystem, and it's again, I have a lot of love-hate relationships with a lot of things. The Postgres ecosystem is great because you have the choice for everything. The distribution itself is fairly small, and for everything you want to add to the standard distribution, there is a lot of choices, but there's also a lot of choices, right? We've seen that with Patroni and PGMan and all that kind of stuff. Here's PG Bouncer, PG Pool 2, PGA Roll, PG Cat, Odyssey. There is like 20 different connection pools. I think most people kind of tend to use the first two. I personally prefer PG Pool 2, and the people hate me for that because everyone thinks PG Bouncer is so much better. Maybe, not saying no. But again, don't build your own thing. There's connection poolers. And there's actually a really nice blog post by Tembo that talks about all those different things. It's really good. And then there is a few other Kubernetes features that aged very badly. Use stateful set. Those slides are like 4 months old. At that point in time, it was a good idea. These days, people have better options. Timescale actually wrote a really good blog post on their own stuff, how they got around the stateful set. Unfortunately, I think it's not open sourced as of now. But there's actually inside the Kubernetes community, there is a project going on to find a better way to do this. Because that was created 6 years ago, basically when the data on Kubernetes, stateful thing on Kubernetes thing started. And it's, yeah, it works. Let's say it that way. It kind of works, right? But by the way, gamers around? I know Chris, I know. What is that? Huh? Replica. Oh, you're actually the first one to know that. I'm scared. OK, and then there is a few things very Kubernetes common, I think, not super specific to Postgres. You want to make sure you use the right network policies. Don't also do this on dedicated hosts. You have enable TLS, right? You want to set up security policies. Configure role-based access control if you think that is important, and you should. You should think that. And then there is some cool tools like OPA and Kyverno that basically being deployed into your cluster and go through between all of the API calls to the Kubernetes API and stuff like that. And you can configure policies, like which pod is actually able to mount a volume, which pod is able to connect to some other service. At least for Kyverno, and I'm not sure if that is still true, but that is something one person at least told me about, specifically Kyverno. It has a great default, which is block everything, right? It's security, sounds good, except for the Kyverno service itself crashes, because then it can't restart it itself anymore because it is blocked from restarting itself. I'm not sure if they fixed it. I hope they did, because that is, I mean, it's secure, right? We don't have to think about that. But in general, I think those policy managers are great. OPA, by the way, is the open policy agent, in case somebody wonders. And we have a great podcast episode with one of the guys from it. In terms of observability, I guess that's not an uncommon topic. Who uses some observability tool these days? Which ones? Just scream anything. Prometheus. All right. All right. Nobody with Dynatrace, New Relic, like AppDynamics, like the obvious big ones. OK, some people are like, yeah, we're using that. Instana, or used Instana in the past? At least one person. Yes, yes. Still? No. Why? Because it was acquired by IBM. It was acquired by IBM. That's the reason. After it was acquired by IBM. So the answer is it got slow after it was acquired by IBM. Seriously, I had the same thing. We were actually using Instana after I went on to my own startup, and that was exactly what happened. So I'm not making jokes here. I'm not making stuff up. Anyway, you really want to make sure you have a good observability in place. You remember, like, hidden layers, abstractions, all that kind of stuff. Good observability tools help you solve that and kind of make it visible when there really is something happening. And get some alerting in place as well. There is Prometheus. For log, there's the log collector. Do some aggregation analytics. I really am a fan of traceability, to be honest. And as I said, scratch the Instana, right? Scratch it. Don't do this anymore. But we heard Prometheus. We heard Victoria metrics. There is so many different tools, and they all are really good. My old colleagues from Instana now started -0, in case somebody wonders. Just another observability tool. Maybe somebody wants to look into that. And then there is the important thing, right? We're talking about Postgres on Kubernetes. And for a reason, the operator is the last thing I'm going to talk about, because it's also the most important one. If you want to do this, don't take the Postgres image, deploy it into Kubernetes, and like, yay, we're good, right? Don't deploy like PG Bouncer or Patroni yourself. Use an operator. My personal feeling is OK, that's not what I expected. There you go. But don't use Helm charts. That's what I thought comes up next. So the Postgres operator is basically your database operator, your database management, your DevOps, whatever for Postgres, and for whatever the operator supports, like Cassandra and stuff. The operator basically looks at what do you want in terms of a database, or in terms of the deployment. I want 3 instances. I want X. I want Z. And it makes sure that this stuff happens, right? It basically takes the Kubernetes API and extends it with some automation and stuff like that. It does all the good thing. I said it brings the cloud nativeness to PG, and we're gonna see a quote at the end. But it basically integrates Postgres with Kubernetes, right? It takes all the important bits from Postgres and all the important bits from Kubernetes and merges them together and puts the automation into the right place. Because we're in the Postgres ecosystem, and I think that's a general thing for operators, there's quite a few, and that's just like a small example. And again, we have this like weird Zalando kind of thing, right? The most obvious one in the Kubernetes space right now is Cloud Native PG. It's a great choice, no matter what you do. I personally am a fan of Stackgrass. Not just because I know Alvaro, who owns Ongrass, but also because I think it's great. As you see, for that kind of stuff, like the standard things, it's all good. If you run a Postgres 9.6 in production, kubedb is your only chance. There's literally nothing else that supports that version anymore. And then there's a couple of other things like hot standby, warm standby, all that kind of stuff. It's all green. It's all good. Nothing fancy here. And then there is a few things where it's kind of weird. Like, why does Crunchy not really support automatic, or nicely support automatic backups via Kubernetes? That's kind of weird. Same for the Zalando, by the way. The other thing that I find complicated, and I think Cloud Native PG actually fixed it by now. They now use the default Postgres images. But that brings you back to the problem of extensions, and that is where Stackgrass actually has like a fancy magic way of doing that, because they can inject extensions at runtime into the container image, which is really cool. So you basically say, hey, take the standard image, and this is like the couple of extensions I need. And that even works at runtime if you need a new extension. If you need a web UI, that's up to you, right? Who thinks we need web UIs for Kubernetes stuff? OK, one person.
I use Lens, for example, and now I develop a
OK, fair enough. Lens is great. Lens was great until they started to actually force you to sign in.
open source project, and
Yeah, that's fair. No, I agree. I agree. Lens is great. There are certainly some things where you want web UIs, but for a Postgres database, I'm not sure. I mean, there's PHP Postgres, my Postgres, whatever it's called. I don't know. Never used it. Again, there is a lot of stuff. We actually have a blog post about how you choose the right Kubernetes operator. And if you want to see all the Kubernetes, all the Postgres operators, there's Operator Hub, not only for Postgres, but for everything. I think it basically has all the operators that exist. And just look for that. And then one last thing, I kind of hinted at that. I said I would not recommend using the same nodes for your workloads and database. I would actually always say if you run on Kubernetes and you think your database is meaningful and sizable and needs predictable performance, use a node pool, taint it, tell your database deployment, these are the nodes you really want to deploy on, or you're allowed to deploy on, then you basically use it as the automation orchestration layer, right? You're not using it as a resource sharing solution, but you're using it as the deployment mechanism. You remember? I love a single deployment mechanism or a unified deployment mechanism. If you're running a small database, again, doesn't matter. Oftentimes, people actually ask, like, what happens when I run microservices and have like one database per microservice? The answer is don't use Postgres, use MySQL, right? If you don't care for that. And now it's fine, right? In this case, often the databases are super small, and normally you probably don't really care if one dies or stuff. That's normally fine. Pin your database to the hosts, taint the host, blah, blah, blah. And because we're here, and I'm kind of forced to say that, otherwise I'm going to be beaten up, 2 slides about Simply Block, why I think it's the best storage option for Kubernetes. And then we have like a very short, very interesting demo, I think. You remember copy on write. So for us, the most important thing, we're copy on write, meaning anyone using ZFS? OK, so you know what copy on write means. Basically, we're not, if you make a copy of something, we're not making a copy, we're just copying the table of contents, basically, right? That gives us instant snapshots, it gives us instant clones, forks, branches, whatever you want to call it in the terms of databases. I think for Postgres, we commonly call it now database fork. We use standard protocols. We support iSCSI if you really want to use that still. But we also use the cool, fancy new stuff, NVMe over Fabrics in the specific version of NVMe over TCP, meaning you can deploy it into any cloud or on-prem or whatever. You don't need specific hardware. If you want to, there's fiber channel and stuff. Right? We optimize specifically for database workloads, meaning we are super high IOPS. We try to be as low latency as possible, stuff like that, or database adjacent workloads, whatever that might be. There's disaster recovery, which is interesting for on-prem, and one specific thing for like AWS, because EBS volumes, for example, don't have cross-zone recovery. We actually can add that to them. Fancy stuff like that. And we chose the most common and easiest interface, how to present ourselves. We're block storage, meaning we look like every single damn hard disk on the world, right? You deploy it, you connect your NVMe over TCP volume. It looks like every NVMe. If you actually run LSPCI, you will see an NVMe device just as it would be connected locally, and you use it like anything else. And let's really quickly try to do this. It's actually the first time I'm running this demo, so you know, right, live demos and first time, it can only fail. So what I have is I have 2 files, 2 YAML files. Can quickly, yes, I know I'm using nano, kill me, kill me. Huh? OK, I think I'm already dead. So it doesn't do anything fancy. It creates a volume claim. So we want a storage volume of 10 gigabytes. We say as the storage class, we actually want the SPDK CSI simply a block. we built on top of SPDK, that's why. And then we basically just deploy a Postgres cluster. We created a specific image version because it's already pre-populated with some data. That's the only thing. Otherwise, it's just like the standard stuff. And that means if I do kubectl apply, not that one, that one. Oh, wait, I need to create the namespace first. All right, now we can try. Apply, there we go. Right, I apply that. I basically say, hey, take this resource definition and deploy that into Kubernetes, into the namespace test1, and it's doing that. So let's see, kubectl get pods, there we go. Let's see when this is, OK, it's already done. 11 seconds, as I said, that's pre-populated with some data set. So that means I can actually go in here and say kubectl exec. Let's delete that real quick. PSQL username Postgres, because we're so super secure. The database is called, yes. The database is called, let me see my notes, AdventureWorks, right. That was the one we used. So AdventureWorks is one of the existing data sets for Postgres, meaning that you can basically list. You can basically say, give me everything from person. It's some data set, whatever, and let's give me the first 10 items, right? So I can create, it's just pre-populated, nothing fancy. So let's get out of here. So now the interesting thing is, who had the question, first of all, are there developers in here? Like, OK, so some people are actually developers. The other ones help developers getting stuff done? Or how does it work? OK, did you ever get the request or had the request yourself that there was this like one bug that only happens on production data? Yes, yes, I've been there, right? What do you normally, what normally happens like when you have that problem? Yeah, that's bad, but you cannot run against the production database, right? That's not how it works. So what you do is you create a database clone or database fork or whatever you want to call that. Is that a fun experience normally because you have to copy all the data? No, it's not, except for you're running on ZFS. So don't get it out of here. So in this case, what we actually do here is we use the copy and write functionality from Simpliblock and say, hey, we want a new persistent volume claim, again 10 gigabytes, but we want that from our original, right now, live running Postgres database volume, right? So we're basically instantly cloning the volume, meaning that if I run that, apply, and this time we want to that one, what it will do is it will create an instant snapshot from the actual running volume. It will create a fork of that, and it will deploy a new Postgres database, meaning if I look here, there you go, the database is running now. So I can now actually go into that one, exec. Let's delete that one again. I can now go into the cloned database, and I can do the same thing. PSQL, username Postgres. What was it? What was it? Sorry? AdventureWorks. God. That's why I love having people around. Come on. And limit 10. Right, so I have the same data. But the funny thing is, because we are on a clone, I can do whatever I want. And because I'm a really bad developer, you know what I'm doing? Truncate, person. Anyone doesn't know what truncate does? No? Everyone? OK. truncate basically deletes all the data in the table or resets it to default. And because we are in an actual data set, I actually have to say it, oh, by the way, if you find something that you think you cannot delete because there's like a foreign reference or stuff like that, you know what? Whatever. Just go, right? So here we are, and guess what? It's empty. So let's get out of here. And you saw, right? It took like basically no time at all to create this fork, and the data set is like, I think 6 gigabytes or stuff. So meaning I can go into the original database, so that's not the fork, right? And connect to that, and because it is it was a clone, Adventure works. Adventure works. I only need to do this like 20 more times, and then I'm good. I can still go, oh, wait, we're in Postgres, and now it works. So I can go here, and guess what? My live data is still all here. Yay, yay me. Whew. I can be a bad developer now, right? So anyway, that's actually really nice. As I said, there's other solutions that can do the same thing, and I see the pizza arrived, so that's perfect timing. ZFS is another solution, but ZFS only works on a single node, stuff like that. We are actually a storage cluster, so we can do a couple of more things. And you remember I said we're coming back to the cloud nativeness for Postgres. Who knows Kelsey Hightower? OK, yeah. So what happens when Kelsey says something? We listen, right? So Kelsey said if you can run a database on Kubernetes because it's fundamentally the same thing as running a database on a VM, right? The big challenge is that you need to understand that running on Kubernetes does not make it the next Cloud SQL. And that's the important thing. It takes a lot of work away from you. And I think what he didn't say, but what I think is important, I personally love the option to say, hey, I manage my own Postgres. I know exactly what happens, except for the abstraction layer. But I know exactly what happens, whereas on Cloud SQL or Aurora or stuff, they just do magic things, and I don't have a feeling. If something happens on Aurora, it's even worse. I'm not sure who has great experience with AWS support. I don't. Same goes, by the way, for Google and Azure. The support is always you can work on that. You can make it better. Let's say that way, right? So with that, there's 2 important things that I want to leave you with. There is the dok.community, the data on Kubernetes. If you run any kind of stateful workload, specifically databases, on Kubernetes, the data on Kubernetes community is the way to go. They wrote an amazing white paper. So that is where I think you should go to find more information. All right. That was a lot of information. I'm sorry. Questions? Yes?
Do you need to layer something like WolG on top of something like this with cheap clones, or can you just like keep cloning and make persistent clones and like use that as a backup?
Sorry, come again?
Would you really need to layer something like WolG or like any other backup solution on top of storage that allows cheap cloning?
Oh, OK. So the question is, do you really need to put something like a PG backrest, WolG, whatever, like a Postgres backup solution on top of something like SimplyBlock? And I think yes, because fundamentally, first of all, storage is not a backup solution. You can use SimplyBlock and say, hey, I have this snapshot, and I want to replicate it to a separate cluster, so you can make an offsite snapshot, just like with ZFS, where you have ZFS send. But it's not necessarily the exact same thing as a backup. You can build your backup strategy. One interesting thing specific to SimplyBlock, and that has nobody else as far as I know, we actually have our own write-ahead lock, meaning that every single change on the block level is recorded, and you can do point-in-time recovery on a block storage level, meaning you basically have the same option as you have with Postgres, just for every other database as well. In this case, it's really interesting. But as a general answer, I would be careful to claim you can always use it as a storage or as a backup solution. For us, it might be OK to do that because we specifically build things into that. In general, I would be very careful. Yes. Do we support InfiniBand? Yes, we do, unfortunately. Whereas I have to say, I'm not 100% sure about InfiniBand. I know we support Fiber Channel, but because we're built on SPDK and it has all the support built in, it shouldn't be too complicated to make it happen.
So at some point, we were talking about local storage.
Mm-hmm.
Obviously, we want IOPS because we want performance for the database. And you said to avoid using local storage because if the node goes away, we have a problem. But on the one hand, today, like local storage is orders of magnitude faster than remote storage. And at the same time, we have really easy replication with operators. So with that, like, do you think it's still okay to tell people to not get the best performance for the database, or?
So the question is, I said you want a lot of IOPS and you don't want local storage. Is that good? Because it's kind of the opposite action, and that is true. You want the highest IOPS, and I would say use a solution that actually makes sense, right? So for Simpleblock, you can actually get millions of IOPS with no issue from a storage cluster for NVMe over TCP multipathing and all that kind of stuff. What you want to make sure is that you have dedicated network bandwidth, right? Especially when you deploy into something like AWS or GCP or whatever, you want to make sure that you have instances that have dedicated network bandwidth. But apart from that, the network latency isn't like super bad. And if you go for like 2 byte packets, yes, network is bad, but you can go for a little bit bigger packets. And then the throughput and the IOPS is totally fine. It's actually NVMe over TCP is faster than InfiniBand and Fiber Channel. It is. From a latency perspective, maybe not. No. Right. Okay. Let's say you want to have a separate network, but a standard Ethernet network. The problem with so what you said is that Fiber Channel and InfiniBand need to be faster. It's at least from a latency perspective. And that is true, especially when you share the same network for storage and non-storage data. That is certainly true because then you have congestion and kind of stuff. We always recommend have a separate NIC or a separate network interface attached, as I said, with dedicated network bandwidth. Especially on-prem with like 100 gigabit fibers or stuff, there isn't much that you can save. The overhead of a protocol is like so small. The only thing is you still have the TCP/IP stuff. But they've really figured it out. It's not in a way comparable to what iSCSI was. iSCSI was horrible. But yeah, from a latency perspective, you can't get lower. I mean, those protocols are specifically built for it. But from a throughput perspective, you actually can.
Well, I think it's also worth adding, right? I mean, if you really care about latency a lot, then you would run hyper-converged, right? What Chris
Yes.
described earlier. So you still have an option of not running disaggregated.
That's actually a good point. Right, so with Simpleblock, you can run hyper-converged, co-located, whatever you want to call it, and you can disaggregate it. But one thing you can actually do is you can mix that. So you can use the storage in the Kubernetes nodes, especially when you have NVMe locally attached. So you can basically use those and add them into a hyper-converged pool. And the same pool can be extended by a disaggregated pool on the other side, which means you actually get best of both worlds. You get the super local and fast IOPS, but you still get the data. We're actually not using replication. We're using erasure coding, basically a fancy rate, meaning that the parity information will be stored in the disaggregated cluster, making sure that whatever happens, even if your whole Kubernetes cluster goes down, we still have all the parity information, and we can return that. Yes, not on the cloud, or only on GCP, because GCP is the only one that actually gives you the option for RDMA. But yes, there is NVMe ROCE RDMA over converged Ethernet. The term is like a real mouthful, yeah. Probably. To be honest, I don't know, because it still runs on Ethernet. So that. No. The NVMe over RDMA would still run on TCP.
Sure.
Yeah.
On TCP, Ethernet.
On Ethernet, yes, not on TCP. Sorry, yes, on Ethernet.
That's why it's called power.
Yeah.
And maybe a question to reflect back to the audience, but when you asked, who's using TLS, who's using replication, who's using PITR, almost no one raised their hands. I think for PITR, I was the only one at the end. And I was just wondering, is it because people don't need that, or because it's too complicated to implement?
That's a good question. Just let me quickly repeat it. So a question to the audience. That with the question for TLS and point-in-time recovery and a couple of other things, almost nobody had his hands up. And the question is like, do people really don't care? Do they not need that, or do they feel like it's too complicated to use it?
We use TLS, but for the point-in-time recovery, we find it a little bit complex. We simply do the PG dump or PG restore for the whole database and not the PITR.
And you never had issues just using PG dump with like foreign keys and certain other things?
Honestly, the database is not that big.
Okay, fair enough. Okay, so we're coming back to like if you have a sizable database. Okay, fair enough. Yeah, to be honest, I think for small, like non-super interconnected databases, that's totally fine. The problem often comes in when you have like a lot of foreign keys and stuff like that, because then, especially when you have extensions, because then sometimes extensions don't really play well together with the restore.
So for the folks who need point-in-time recovery and want to have it set up easily, I recommend to check out CNPG. It makes
Yeah.
any normal average developer like me into a DBA, and in like 2 minutes you can
Yes.
cluster, make a pretty big database, show backups, show point-in-time recovery.
Yeah, so CNPG is the cloud native PG. As I said, it's absolutely a perfectly viable option. And it's probably the biggest project right now in terms of Postgres operator. All right, if there is no further question, let's get to the pizza.